Welcome to Eng1060. Now, before we start the course, I'll do a few introductions and the unit overview. So for Eng1060, there's basically 3 staff members involved in running Eng1060. So you have Dr. Yihong, who's the lecturer and the coordinator. So she's the main person of Eng1060. She will be lecturing you for the first half of the semester, but unfortunately she can't be here this week and this week, so I will be replacing her for the first 2 weeks. Then you have Professor Murray Rudman. He is also a lecturer from the Mechanical Engineering Department, and he will be lecturing you from week 6 to the end of the semester. So that's for the second part of the course. And myself, I'm Jürgen, and I'm the head demonstrator and also the lecturer for the first 2 weeks. But I'll be the main person to contact regarding any issues with the labs. So to start with, there are no labs this week. The computer labs will start in week 2. Now, before next week, you need to pick a lab using Allocate Plus. So if by the end of this week you're not allocated to a lab, you need to organize that very, very urgently. There's a bunch of seats at the front if you guys want. So the computer labs are compulsory. Okay, so you will have 9 labs this semester. Each lab is an assessment. So each lab will run for 3 hours. You will be doing various tasks. At the end, you will get marked, and this mark will contribute towards your final grade. So which is why it's very important that you are allocated to a lab this week itself. Otherwise, next week, you're going to miss out on the grades for week 2. So if you haven't done so, you can allocate yourself to a lab using Allocate Plus. Okay, so there's a link for it here. If you are doing double degree or with other units, make sure you don't have any timetable clashes. Remember, the labs are compulsory and they are marked. So if you do have any clashes and you can't go to your allocated lab, you need to contact the faculty office on the ground floor of Building 72. They are the ones who can change your allocations. To be able to log into a computer at Monash, so given a number of you here being first year, first semester, this will be your first time at uni, you need to have an Earthgate username and password to be able to log in the Monash computers. And that works for all the computers on campus. So to be able to do MATLAB in the labs, so not only you need to be allocated, but you need to have a working username and password. So make sure you test your username and password to see if it's working, and you can log in one of the computers. If you have any problems with computers, logins and stuff, you can visit the ITS help desk in the Matheson library on the ground floor. So the Matheson library is the library near the campus center, on my left, your right. All the lectures and labs will be available on this unit, for this unit on Moodle. So by now, all of you should have access to Moodle. So if you go to Moodle, Eng1060, you should be able to follow it through and get the labs, lecture notes. The solutions for the labs will be posted on Moodle 2 weeks after you've done the lab. So you can keep checking to be updated. The unit guide is also on Moodle. So the unit guide will tell you what are the objectives of this unit, what do you aim to learn, what are the assessments, etc. So just briefly, your computer labs are worth 18%, so 9 labs each. 9 labs of 2% each. You will have a library session in week 6. that's worth 2%. So for the library session, it is compulsory that you attend the library and the staff member there. So this is organized by Hillary. So the staff member there will take you through the library and show you how to use the various resources, etc. At the end, there will be a quiz, and that's what's worth 2% during the quiz. You will also have an assignment for this course that's worth 10%. So generally, the assignment will be out around week 7 or week 8, and you will have approximately 3 to 4 weeks to do the assignment. And the exams is 70%, 3 hours. Before we get on any further, just need to mention a little bit about plagiarism. Now, plagiarism, in short, is basically copying someone else's work and submitting that as your own. That's the core of plagiarism. So when you do any assignment or lab, if you have used up or if you have used resources that is not your own, so it could be from textbooks or from your friends, etc., you must acknowledge all of the help or the resources that you have used. So for us, for 1060, this doesn't really apply so much because we don't actually do assignments where we have to write essays. It's more like programming. For 1060, this is probably the most common plagiarism that you get. It's collusion. So this is, well, you have two types of collusion. The deliberate one, so this is the first bit. So you submit an assessment that is not your own. So for example, for your Eng1060 assignment, you get someone else to do the work for you, and you submit that as your own. You have group work collusion as well. So you work together with your friends. So again, for the assignment, or even for the labs, you work together with your friends, and you submit a piece of code that is in collaboration with 3 or 4 people. So again, all these will be considered plagiarism. So what you do is when you work together to complete the lab work, so you can discuss the methodology of how to write the code. You can discuss what is the question asking. You can sit down and brainstorm how are we going to do this. But when it comes to writing down the code, you should do that on your own. To sort of try and get or catch a bit more plagiarism or prevent students from doing plagiarism for 1060, your assignment will be marked in your presence. So the assignment will be marked during the last lab. You will have to be present. The demonstrators will mark your work and ask you questions about your code. So you will get about 15 minutes of lots of questioning. If you can't answer any bits in your code, chances are you didn't write the code yourself. Because if you did it, you will know exactly what everything is doing, unless you have reference where you've obtained code from. So again, if you are caught plagiarizing, there are serious consequences. You could be as little as getting, well, the best scenario is you get 0 for the assignment or for that lab. So that's your best scenario. The worst scenario is you're excluded from the course. So again, depending on what or how many times you're plagiarizing. You can attend workshops in the library if you want to know a bit more about how to avoid plagiarism. So there are some dates when they are running in the Hargrave Library. Okay. Now this unit is worth 6 credit points. So you're doing 4 units per semester. So you will have 5 contact hours at uni. So 2 lectures per week, 2 hours. 3-hour lab, which starts next week. That's 5. So you need to spend about 7 hours a week reviewing the lecture material, preparing for the lab, and practicing at home, or in your own time, I should say. From experience, maybe not in week 2, but in the later weeks, a number of students have, well, they've told me or they've reported that they do actually spend about 5 to 7 hours per week to do the labs. So the labs will get harder as the weeks go by. So like I said, not for week 2, but the labs are intentionally done that way. It's to try and force you to get a bit more practice in MATLAB. So for the lectures, 2 lectures per week, during the lectures, we are going to cover a lot of sort of theory and topics that will be assessed for this course. We will also demonstrate some simple MATLAB examples during the lectures. The lectures are recorded, so you can view the you can listen to the lectures online. So this is wrong. Should be Tuesday and Friday. So you can listen to the lectures online. However, when you listen to the lectures online, is not a replacement for not attending lectures. So hopefully by the end of the semester, I see that many people, or we see that many people here. What you won't get on in the lectures online is when we run MATLAB examples. So going through MATLAB examples, doing all these annotations on the screen, you won't get that in the recording, because the recording is only the audio file. So you can skip through the lecture notes, and you can only hear it. So it's mainly for, you've been to the lectures and you probably missed out on some bits here and there. But if you've been to the lectures and you listen to the audio afterwards, it will make more sense, because you will know exactly what was going on at which time. Now, just quick show of hands. How many here have done programming before? Any form of programming? Okay. How many of you have never done any programming? Good. So that's why we're here. Now, those of you who've done programming, you will know that the first statement here is true. Programming requires a lot of practice. Okay? There's only so much that you can learn in programming. So the whole theory of programming is you learn the concept. Okay, so you can learn the concept of how to write a program. What are the steps involved in being a good programmer? The rest is just the different language that you use. So you have a lot of programming languages. So for example, we are going to be doing MATLAB for this course. You have C, you have Java, you have HTML. I mean, the list is endless. Each and every one of them will have different syntaxes, different language, we'll call it. However, the methodology to write a code will be the same or similar. And once you learn a bit about the language and the syntax, the only way to get good at it is by practicing. So the more code you write, the more efficient you will become in writing codes, the more commands you will learn, and the more or the better you will get at seeing what's the best way and how to write the code. So that's where the computer labs will come in handy. So like I said, the labs are designed to let you practice problem solving. Now, unfortunately for you, or fortunately for you, I will be setting the labs in a way that you will be required to do a lot of work at home or in your own time before coming to the labs. So the labs will be set up intentionally so that it's a little bit hard for you to finish within 3 hours. So again, you're meant to spend about 7 hours per week outside of the contact hours with practicing MATLAB. So, but again, it's not so much that it takes a long time, but it will be only the first few weeks until you get used to it, because the more you practice, the better you will get, and the faster you will be able to go through the lab questions. The demonstrators in the labs will be helping you with your coding techniques. So they will help you practice correctly. So what you're doing wrong or in your methodologies, etc. And they will be answering your questions, but more so, they will be guiding you through how to solve the problems. So remember, the labs are assessments. So if you put up your hand and ask, what's the answer for this? You will not get the answer. Okay? It's an assessment. What the demonstrators will be there for is to mainly guide you through how to get the solution. So this is a little graph which, well, we probably should have did that. I can assure you this graph is very similar for every semester. What it is the continuous assessment, which is the labs and the assignment. So that's worth 30%. Okay? If you are within sort of that zone between 20 to 30 in the continuous assessment, what that means is throughout the semester you have put in a lot of effort to do the labs, to do the assignments. Okay? Like I said, the labs can be a little bit tricky sometimes. So you put in all the effort, all the hours to do them. And your final mark, so when you go to the exam, most of the students, they were in that zone. So you can see from this graph is, once again, with programming, it's practice. The more you practice, so you get higher marks for the labs, the more you know about MATLAB. For the exams, we have 3 hours to test you on all the topics. So we can't really make it overly hard. Imagine we're doing 3 hours to test you on one topic every week. And then we have 3 hours for all topics. So most of the time, students who've done all the labs and know what they're doing, they just cruise through the exam. That's always the case. So that's when we'll know who has plagiarized. Students who get like sort of high marks here, but low marks in the exam. So that's where the plagiarism gets caught. Okay, we do have a recommended text for this unit. So it's Eng1060 Computing, prepared by Y. Holy. Now, you don't really need to buy this book straight away. All the materials that you will need will be covered in lectures through MATLAB, the labs, and the assignment. You can access this book in the library, but the book has a lot of information. In fact, most of the lecture notes are taken from this book. So the book has extra information about various topics. You can borrow a copy from the library, see if it's very useful for you. If it is, then you can buy yourself a copy. Okay? So MATLAB is installed in all the engineering computer labs. So it's building 60, 35, etc. You can run MATLAB from the Windows Start menu. You can also apply for after-hours access to building 60 through this link. So if you want to spend more time in the computer labs. So any questions about the overview of the unit? Yeah? Good? All right, so this week, yeah? There's nothing? Okay. All right, I'll have a chat with Dr. Yihong and see if she probably will be doing that at some stage this week. Okay. So just briefly, the unit again. At the start, I mentioned you have, well, 2 main lecturers for it, Dr. Yihong and Professor Murray. So the first part is MATLAB programming. So that's week 1 to 6. So I will be replacing Yihong for week 1 and 2. And from 3 onwards, she will be taking over. So from week 1 to 6, you will be learning about MATLAB programming. Okay, so you learn a lot about what is MATLAB, different syntaxes, and how to write little bit of codes, etc. part B is numerical methods with MATLAB, and that will be lectured by Professor Murray. What numerical methods is effectively solving mathematical problems, but you will be solving that using MATLAB. So part B will be built upon part A. So by the end of week 6, you must make sure you're up to date with the first 6 weeks. From week 7 onwards, all the topics will be built upon assuming that you already know MATLAB language. Okay, so by week 6, you need to be quite good at MATLAB. Don't worry, we will be giving you a lot of help along the way. What's engineering? So most of you here are doing engineering, all of you, I should say. So effectively, what you're doing in engineering is trying to reduce various systems to models. So you have a problem somewhere. So you try to take that problem, you reduce that to some models, hypotheses, and you test this model experimentally to get a theory. So you have a lot of theories in science and engineering, the Newton's laws, Hooke's laws, plenty of laws in mathematics. Engineers, so what we do is we create new technology using those scientific models. So the scientists do all the hard work, they get all the theories, just give it all to us, and now we apply those theories to technology or to existing real-life situations. And the whole of what we do is to try to make our life easy. Okay? So to create convenience and make things better. I think there was a sign, I don't know if it's still in Building 72, that said, "People dream, engineers deliver." You guys seen this? So that's basically a good motto for engineers. So people dream about something, and engineers will make it happen. So for example, you have the electromagnetic propagation, so using antenna. That will be built upon, then you have Wi-Fi technology, and then you have the invention of the battery, which then gets used into so many devices, etc. So we're just getting through of the sort of methodology on how to solve problems here. This will be used, a similar analogy will be used for MATLAB. So again, if you have to solve a problem in science or engineering, you reduce that to a model, and then you try to solve that. So for example, when we do build up with engineering models, so what we do is we take a real life problem, we try to simplify that into something that we could solve. When we simplify that model, we make assumptions. So the number of assumptions depend on what we are trying to solve and at what level we are trying to solve it. For instance, if we are solving to try and find to look at designing a bridge, and we're looking at, there's a 1,000 kilogram car on a bridge, and it places a force of 9810 Newton to the road surface. So using that, we can design what sort of road surface to put in. Okay, so how thick should the concrete be, etc., or not concrete, but asphalt. So what we've done here, we've taken the weight or the mass of the car, multiplied by gravity to give us the weight. However, if we use just this weight in our design to create the asphalt, it's not really a realistic approach. What we've done here, we've made a lot of assumptions. We've assumed that the dynamics is not included, which means that because when the car moves, the weight on the bridge is not the same. We've discarded the effects of the wind, for example, wind loading. We've discarded vibrations. So depending on the level at which we are doing it, there's a number of assumptions that we can make. So this would probably be for grade 1, if you have to do that calculation. So the more we get evolved into reducing the number of assumptions or trying to get more and more complex in our design, what we do is we end up using computers, so we program computers to model and simulate complex systems. So that's what the computers are. So once again, well, when you look at the computer, it's effectively just a box with a bunch of electronics inside. So it's up to the engineer or the software developer to write a code that will make those electronics do something for us. So that's where the programming comes in. And that's where MATLAB will come in for you. So you have MATLAB, so which means you have a software, you have a computer. So you need to write programs to basically get the software to do something for you. Now, smartphones are very popular nowadays. Okay? So hopefully most of you here will have a smartphone, which means you will see that a smartphone is basically a computer on its own. So with the popularity of smartphones, from your smartphone you can access lecture notes, you can work as a laptop, you can go through GPS, you can play games, and 5% of the time you can actually talk to people. So the 95% you're not talking, but you're using it for something else. So what it is effectively a bunch of programming. Again, you have different companies uses different styles of programming. You have Windows Phone, you have the Android, you have iPhone. They all use different programming languages. All of them have their advantages and disadvantages. MATLAB is used everywhere in engineering and science. So you can check this. If you go to the seek.com, so you go into jobs online, and you just type MATLAB in there, and you'll see how many jobs come up. So this is like a lot of jobs that are released, whereby they actually put in there that you have an advantage if you know MATLAB, or knowing MATLAB is essential in some cases, but you do end up using MATLAB a lot in industry. So these are some of the companies that actually use MATLAB to solve engineering problems. So from this unit, what we expect you to know is you will learn computing through using MATLAB. So you will learn the MATLAB programming language. You will learn numerical methods, so how to solve mathematical problems. And most importantly is you will learn how to solve those problems using a computer. You will also learn how to present a solution. So you take a real-life problem, you simplify that problem, solve it using a combination of mathematics and MATLAB, and present your solution afterwards. So just briefly on what are numerical methods. So numerical methods is basically a mathematic technique that actually use the concept of subbing in to find the solution. So what numerical methods is, for example, if just say we say that 2 plus 4 equals to 6, right? Do you agree with this statement? Yes. Hopefully yes. However, what you have done here is you have taken, or in your head, you have done 2 plus 4, and you know that the answer is 6. Yes? So that's the direct way. That's what scientists or mathematicians will do. when you do numerical methods, what you do is we do trial and error. So it's a bit like subbing in. We try. Is 2 plus 4 equals to 1? No? We try. Is it 2? No? 3, 4, 5, and then 6. And then we get to 6. That's the answer. Good. So then we output that as a solution. So what you've done here, that concept is effectively doing trial and error. The same will work is, let's assume you have a graph, and you're trying to find where does that graph crosses the x-axis. So let's say this is y and x. So you're trying to find this point. So at this point here, the value of y equals to 0. Okay? Now, let's assume that this equation is given to you by what's going on there? That works? Yeah. So let's assume that this equation is given to you by x squared plus, I don't know, 10x on log x squared, multiplied by 4x plus 2. Okay? So that's your equation. So if I ask you, obviously what you're trying to do here is solve for the case of y equals to 0. So which means solve this equals to 0. That's easy. Just solve for x. So how would you do that? Right? What you can try and do is, we'll just try values. So let's try to put in 1x equals to 1 into the equation. When we put x equals to 1, will the answer be 0? If it is, then 1 is a solution. If it's not, let's try 2. No good, let's try 3. How long will it take you to go through endless possibilities of numbers? Ages, and it will take you a lot of trees. If we have to do it 0.001 and then 0.002, etc., you're never going to finish. So that's where computers come in handy. So you can write a program that will make the computer do this hard work for you. So you get the computer to try all the possibilities. Computers, even smartphones, can do that many operations per second. Computers can do even more. So that's essentially what numerical methods is all about. So it's a bit like subbing it to try to get to solutions. One of the important things, we're probably not going to cover that into much details for this course, but when you do programming, an important thing is memory allocation. So how much memory will you allocate to do a certain task? Now, the reason we're not going to cover that into too much detail is for Eng1060, or for what we are doing in MATLAB, if we leave it as a default, as in we let MATLAB decide how much memory it wants to allocate to a certain task, it will work fine. But generally, as you get more and more advanced, if you leave the memories on default, so that means you let the program decide what sort of memory it will allocate to perform a certain task, it could be, let's say it could allocate this amount of memory to do this task. So a lot of this is being unused. This, you will find that a lot, again, if you have a smartphone. So you have a phone, you start playing a game, halfway through the game, the computer or the smartphone will just stop working, will hang itself, and you have to restart it. So that's not a good thing. But we'll get to that later on. You can use MATLAB to model robotic arms, robotic manipulators. So this is all the cool stuff. You use MATLAB to control or to model digital cameras. you can process images using, you can use MATLAB or you can use programming. So mainly if you're doing Photoshop and things like that. Bionic vision, telecommunications, etc. So MATLAB here, so briefly, when you load up MATLAB, so again, try on the computer labs. So when you get a chance, go to the computer labs, try to log in a computer, go to the start menu, and look for MATLAB. I believe you guys will have MATLAB 2013 or even maybe 2014 in the computer labs. On my laptop here, I've got MATLAB 2007. Okay? But nevertheless, there will be quite a bit of difference, but the concept is the same. On the MATLAB interface, you have 3 main windows. So once you open MATLAB, you should end up with those 3 windows. The green one here is your current directory. So this is basically the directory where you're working from. The directory can be anything. You can be working from the desktop, from your pen drive, create a new folder. You have another window here, that's the command history. So this is basically remembering the different commands that you have used. And you have the main one, the command window. So in the command window, you could use that as a calculator, which means you can actually type in like 2 plus 2. It will tell you what's the answer. But the command window also outputs the solutions. So when you write a program, so you will write a program into an editor. So I'll quickly show you that. All right. So I've already loaded MATLAB. The reason for this is my computer has 1 gig of memory. It takes a bit of time to load up MATLAB, so I've preloaded that already. So there's the current directory. So in this case, I'm working into this directory here. So users, presenter, blah, blah, blah. So you can change that to anything you want. So if you click on this little button here that has 3 dots, so it will give you another window where you can browse for which folder you want to work in. Okay, so I'm going to make a new folder. Let's call it Lecture 1. Browse. Okay, so now we're going to be working in that folder. The command history is basically remembering the previous commands that we have been running on this machine. And the command window is again where it will output the answers and where you can use it as a calculator. For example, if we use MATLAB as a calculator, so if I write 2 plus 2, it'll give me 4. All right? So 7, 4. What I can do is, we can write a program. So if you go to File, and then you say New, M-File, so what will happen is, it will open up an editor. So this editor is basically, it's a bit like a Notepad editor. So in the editor, you can write your program. Okay, so this M-File or MATLAB editor is what you are going to use all the time to write your programs. So right up from week 2, we will get into the habit of writing programs in editors. So meaning we are writing a script, and you can save that script, and when you execute that script, the answer will come in on the command window. So for instance, if we write 5 plus 2, 5 plus 6 in here. So I need to save that. So we'll call it I'm always worried it's gone off. Let's see. So let's call it trial. Okay. And you can go to File. Oh, sorry, we can do this, the little play button here. So you can see when you hover your mouse over it, it says Run Trial. Now just before I click on that, so you can see what happens here. So if I run it, you can see that the answer comes up onto the command window as 11. Okay? So that's basically the whole concept of it. Now, over here, what we've done is we've just written one line. So you could write programs using 100 lines to do various things. So you do one thing, then you go to the next, etc. So you write the whole code. When you finish, you click on Run, and it will give you the output on the command window. But more of this will be coming in later. You can use MATLAB help if you have any queries about sort of, how to use different commands. So if you go to the MATLAB itself, so the help file, you can press F1 or this, etc. You can go through a list there of, you can ask questions and read about different commands and what they do. So again, to summarize that, so in your week 1 to-do list, so hopefully by now you just have a little appreciation of what is MATLAB. So at least you know what it is, where to find it. But make sure you have an Authkate username and password that works. Make sure you are allocated to a computer lab session. Okay, visit the Eng1060 website to read the unit guide, which again I will get Yihong to upload very soon. And we'll continue a bit more on the basics on Friday.